All right, students, hello. It's me again, Mr. Davis, your favorite teacher's favorite teacher. It's true. You know it. In this video, I'm going to go over the lesson 1 review that you may have done. It is on page 54. 1 through 6 is the chapter 1, lesson 1 review. I just want to make sure you have the right answers and that you are not missing anything. So let's just jump right in. Number 1 says, displacement is a or and blank because it has both magnitude and direction. I'm pretty confident that you know that that means that displacement is a vector because it has both magnitude and direction. So you should have that written down on your paper. You can remember, pause this video to make sure you get what you need. Number 2, it says define a reference point in your own words. Now, a lot of times students want to just copy the definition. But let's say, for example, we're using this map right here, and you want to tell somebody where City Hall is. Okay, you can see here that each block is 500 meters. So if you're trying to describe to somebody that's visiting this city where City Hall is, you might say that it is 500 meters east of the library. And in this case, the library is a reference point that help you find where City Hall is. You could say it's 500 meters east and 500 meters south of the art museum. In that case, the art museum would be your reference point. But basically, I think that a good way to state it is that a reference point is an object or location used to help describe the position of another object or location. So for example, if somebody was trying to find APW and you said it's in Los Angeles, well, Los Angeles is the second largest city in the United States, so they'd have to look a lot of places if you only told them that it was in Los Angeles. Now, if you said it was across the street from Chester Washington Golf Course, well, there's only one Chester Washington Golf Course in Los Angeles, so that'll make it a lot easier for them to find the school by using a reference point. So that's why this question, that's what this question is asking you when it says, or what I'm saying, when it says define reference point in your own words, which we're going to be able to come up or use again when we get over here to question 5. But let's continue. It says, which of the following statements is true? And all of these statements are asking you about displacement. Now, I want to remind you that displacement is the total distance from where you started. So in this picture, you can see that this object, if you go from here to here, this person has walked 40 meters. Well, displacement is a vector, so you need size and direction. So the distance this person traveled was 40 meters because that's just how far they went. But if you put how far they went plus their direction, that will give you the displacement. So the displacement is 40 meters east because the person is 40 meters from where they started. Now let's say this person walks this 40 meters east, but then they turn and go 30 meters north. So you can see that 40 plus 30 is 70. This person has walked a distance of 70 meters. However, the distance from where they started is a straight line. Okay, so from here to here is 50 meters. So this person's displacement is 50 meters northeast of where they started because that's how far they are in the direction from where they started. Now the thing about displacement is, again, it's how far you are from where you started. So let's say this person walks completely around the block. This person would have traveled a distance of 140 meters, but because they're back where they started, the displacement is 0. Because that is the difference from where they started, and then they're right back where they started. Okay, so the answer to number 3 should be, the answer is D. Okay, sometimes the distance traveled equals the magnitude of the velocity vector. Okay, but not always, but sometimes, because that's what we have here in this first example. The distance is 40 meters, but also in this case, the magnitude of the displacement vector is also 40 meters because this person is only 40 meters from where they started. So displacement, again, is a vector, has size and direction. The size is sometimes the same exact distance as the person has traveled, and that's why the answer is D for number 3. Number 4, it says state the relationship between the plus and minus signs when used with a reference direction. Okay, a plus sign is used to show direction towards or in the direction of the reference point. The minus sign is used to show movement away from the reference point or in the opposite direction of the reference direction. So you can pause this and write that if you want. Number 5, we already touched on this. It says, explain the importance of communicating the reference points when giving a position. They're asking you, why is it important to tell someone where the reference point is when you're giving them the location of an object? That's what this question is asking. A lot of people didn't understand what the wording meant. It says, explain the importance of communicating. Communicating is when you're talking to somebody or you're relaying information. It could even be writing, like you want to write down the directions somewhere. But why do you want to give a reference point when you're trying to tell somebody where something is? Again, okay, it helps you give a more exact position by decreasing the possible locations for an object. So again, like I said before, if you tell somebody the APW is in Los Angeles, there's a lot of possible places that the school could be, but giving a reference point decreases the possible places it could be. So if you say it's across the street from the golf course or Chester Washington golf course, okay, that decreases the possible places it can be and makes it easier for somebody that's looking for the school to find it. All right. The last one, number 6, it says copy and fill the graphic organizer below to identify the two parts of a displacement vector. Well, you know that all vectors have size and direction, but the specific size of the displacement vector is actually the distance from the reference point. Okay, so if you say I went 50 meters east, okay, or if that's your displacement, then that distance, that 50 meters, will be the distance from whatever reference points you pick, and the direction will be whatever direction you are from your reference point. All right, so now these down here, I'm going to use 2 pieces of paper because I want to make sure that so I don't have to flip back and forth. All right, down here, let me grab a piece of graph paper real quick. All right, a lot of people are having trouble with this. When it's quite simple, you just need to follow directions. Okay, so it says on the graph paper on the other side of the paper, and again, I'm going to just use a separate piece of paper so we're not going back and forth. Okay, you can see down here I put a reference point, which is our origin. All right, and then it says use them to do the following. So it says go 15 blocks east and label it A. Okay, and then it wants to know the distance and the displacement if you do that. So here's our origin, okay, and it says also that each one of these blocks down here tells us it's 10 meters. Okay, so if we count over 1, 2, 3, 4, 5, we get to 15, we'll end up right here. Okay, and so you get over to 15 and you label it A. So we've done that, and it wants to know the distance. Okay, well, we went 15 blocks, and if each block is 10 meters, okay, 15 times 10 is 150. So our distance would be 150 meters. We cannot forget the units. It's also asking us for the displacement. Remember, the displacement is the size and direction, and the size of the displacement vector is the distance from where you are. And so we went 150 meters east. So that is our displacement. It's 150 meters east. Okay, and that's it. That's our size and our direction, our magnitude and the direction. It says go 25 blocks north and label it B. Then it wants to know the total distance. So we just need to count up 25 blocks. Okay, so let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 is right there. If you need to pause once again and count carefully, please do that. We're going to label it B, and they want it to know the total distance. Well, if I went from A to B, if that was 25 blocks, 25 times 10 is 250. But they wanted to know the total distance. So that's from A to B. That's 250 plus this 150 I had gone over here. 150 plus 250 is 400. So the total distance I have traveled is 400 meters. All right. Then it wants us to go 10 blocks east. All right. It says, and it tells us that's where C is for number 3. So east is going to be to the right. We got to go, it says how many? 10 blocks, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there's C. And then 10 blocks is in the 10 meters each. 10 times 10 is 100. I had already gone 400 meters, so if I add 100 to that, my total distance is going to be 500 meters. All right. Moving right along, it says D is 3 blocks north. Okay, so we go 3 blocks north to D. 1, let me see, yep, double check with it. 1, 2, 3. So D is going to be right there. Okay, that was 3 times 10 meters. That's 30 meters. So my total distance here is going to be 530 meters because I went 30 more meters. Then it says E is 13 blocks south. Okay, so I go back south. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, there is E. Okay, I went 13 blocks. 13 times 10 is 130. I add that to here. That's going to give me 660 meters total distance I have traveled. I mean, look how easy this is. If you just take your time, it'll be just as easy. Okay, then it says to go 25 blocks west. Okay, I already know that if I count 25 blocks west, okay, I go straight west, I get to 25 blocks. I already know it's going to be right here because I did this before. I planned it this way for you. So that's F. So that's another 250 meters. So right now, if you need to do your math, okay, 200, because I went 25 blocks, 25 times 10 is 250. If I add 250 to this, let's see. You can do your math over here on the side. 660 plus 250. Okay, that's going to give you 910 meters total distance traveled. Okay, and it wants to know the displacement. Now remember that displacement is the size and direction from where you started. Well, we started here. Well, let's see how many blocks we are. Okay, we are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I messed up. Hold up. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 blocks. Okay, so that's 15 blocks. So 15 times 10 meters, each block is 150. So I'm 150 meters north of where I started. Okay, so that's my displacement. Because even though I've gone a total distance of 920 or 910 meters around this whole area here, at this point I'm only 150 meters north of where I started. Then it says to go 15 blocks south and label that G. If I go 15 blocks south, then I'm back here at the origin. I'm gonna label that G. Okay, and so 15 blocks is 150 meters. If I add 150 to this, I get 1,060 meters total distance. I've gone 1,600 or 1,060 meters total distance, but I'm back where I started. So my difference between where I started and where I stopped is 0. So that is my displacement. I am back exactly where I started, and that is that. So now move on to the next thing. You should have been done with this already anyway. Just find where you are in the flow chart and keep on going.